online chemistry class. Our topic is chemical thermodynamics. Now let us discuss the part number 4. So today let us consider the enthalpies of physical transformation. So enthalpy of phase transition. So all are familiar with enthalpy. Enthalpy is nothing but sum of the internal energy and pressure volume type of work. Now all are familiar with this phase. Also there are three different phases: solid, liquids and gases. Now we have to consider the enthalpy change during the phase transition, means when solid is converted into liquid, liquid is converted into gas, or reverses the process, then how much heat will be absorbed, how much heat will be evolved, or how much work will be done on that system or by that system, that can be calculated by using the enthalpy change without changing the chemical composition and having at constant temperature and pressure. So let us consider the first process, fusion. So all are familiar with fusion. Solid is converted into liquid. So don't write the definition like when. It is the enthalpy change when solid is converted into liquid. So this is not valid for the answer. So what is the correct definition? Enthalpy change that occurs when 1 mole of a solid is converted into liquid without change in temperature at constant pressure is known as enthalpy of fusion. So you have to mention the word 1 mole, then keeping the pressure constant without change in temperature. So all these things you have to mention your answer. Then let us consider the example: H2O solid, that means ice, is converted into H2O liquid. So FES means it is a enthalpy of fusion. That's why FES for fusion is word is written as a suffix for that triangle as a subscript. Then what is the value? Plus 6.01 kilojoule per mole at 0 degree centigrade. So this indicates that enthalpies for this reaction it is added. So when 1 mole of solid melts at 0 degree and 1 atmospheric pressure, what is the change in enthalpy? 6.01. Now what is the this much amount of heat we have to supply to ice, and then it undergo process of melting. What is the opposite process for fusion? It is a freezing. So at 0 degree your water in liquid state get converted into ice. So for this conversion, reverse conversion, H2O liquid to H2O solid, same value but with negative sign. So delta freeze enthalpy means enthalpy of freezing is minus 6.01 kilojoule per mole at 0 degree, and that much amount of heat will be given out by that liquid water to convert into ice. So I think all are familiar with this. So only the if process is opposite, reaction is reverse and value will get change by only changing the sign. The figure will be same, only the sign will get changed. Now next is enthalpy of vaporization. So VAP is written as a subscript for delta. So what is the enthalpy of vaporization? Enthalpy change accompanying the vaporization of 1 mole of liquid without changing its temperature at constant pressure. So if we observe these two definition, enthalpy of fusion and enthalpy of vaporization, most of the words are common. In fusion, here fusion word is there, and in case of that fusion, solid is the word, here it is liquid, and remaining wording is same. So it is very easy to remember we remember one definition we can write the another definition by observing only the process. So vaporization means H2O liquid gets converted into gas. So plus 40 kilojoule per mole, and vaporization of water can take place at 100 degrees centigrade. So 40 kilojoule amount of heat will be supplied to that water, and then it gets converted into water vapors. So all are familiar with the boiling point of water, and this can take place at boiling point. Now reverse is the case. If we change the temperature, value will get change. So if we reduce the temperature from 100 degree to 25 degree, we have to supply 44 kilojoule per mole amount of heat to that system or to that water in liquid state. So here temperature word changing the without changing the temperature. So this temperature word is also important. Okay, this temperature word is important, remember this. So if change the temperature, value will get changed. So do not forget to write the temperature word. Wordings are important when we consider the definition. Now what is the opposite process for vaporization? It is condensation. So condensation to vapor is accompanied with, here heat is absorbed. Now opposite process, heat is released. Only the sign will get changed. So your reaction becomes reverse. So H2O gas gets converted to H2O liquid. So your word is condense, and minus 40.7 kilojoule per mole at 100 degree. So the opposite. Then next one is the enthalpy of sublimation. It is the enthalpy change for conversion of 1 mole of solid directly into its vapor at constant temperature and pressure. So H2O solid can be converted into H2O gas. So value for sublimation is 51.08 kilojoule per mole at 0 degree centigrade. So conversion of solid to vapors occurs in one or two steps. First step is melting of that soil leading to liquid, and second step is its vaporization. So the enthalpy change is the same, since enthalpy is a state function. At 0 degree H2O solid to H2O liquid, what is the value of enthalpy of fusion? It is plus 6.01 kilojoule per mole. Then H2O liquid to H2O gas, that means enthalpy change for vaporization is equal to 55.07 kilojoule per mole. So what is the combination of these two? This H2O liquid get cancelled, H2O solid gets converted to H2O gas. So this enthalpy of sublimation is the sum of enthalpy of fusion and vaporization. So you can observe same thing in your diagram. Okay, solid is converted to liquid, fusion. Liquid is converted into gas, vaporization. And solid can be directly converted into gas, that is sublimation. So here you can easily understood, and one law is based on this, and that is the Hess's law of constant heat summation, that we will discuss later on. Now next one is enthalpy for atomic or molecular change. So here we consider the enthalpies related to different processes. Now enthalpy for the atomic or molecular change. So consider the first, that is ionization. So it is the enthalpy change accompanying the removal of an electron from one mole of gaseous atom. So when we remove one electron from sodium gas, it gets converted into sodium positive ion. So one electron is lost, so one plus is the charge, and how much it will be required? It is 494 kilojoule per mole amount of heat will be supplied to that system. then the same amount of heat would be required for ionize 1 mole of sodium atom. Okay, because it is the same. Then opposite for loss of electron, it is enthalpy of ionization, or all are familiar with ionization enthalpy that we learn in periodic table in 11th standard. So what is the opposite for loss of electron? It is gain of electron. So definition is electron gain enthalpy. So the electron gain enthalpy on the other hand gives enthalpy change when 1 mole of gaseous phase atom of an element gain or accept 1 electron and they form anion. So let us suppose chlorine gas gain 1 electron gives chloride ion in gaseous state. So Eg for electron gain enthalpy, and it is minus 349 kilojoule per mole. That is electron gain enthalpy of chlorine in gaseous state. Now enthalpy of atomization, formation of atom from the molecule, and what is that? Enthalpy change accompanying the dissociation. So we have to break the chlorine-chlorine bond, and that chlorine molecule get dissociate into chlorine atom. Dissociation of 1 mole of gaseous substance into gaseous atom, that is called as atomization. So word itself indicate atomization means molecule get converted to its atom. Chlorine gas gets converted to chlorine atom. How much is the enthalpy of atomization? 242 kilojoule per mole. Or we can convert methane into carbon, and enthalpy of atomization is 1660 kilojoule per mole. Now next is the enthalpy of solution. So we can prepare a solution of any substance. Let us suppose we have to prepare a solution of sodium chloride. So we take excess of water and we have to measure how much enthalpy will be required. So enthalpy of solution is the enthalpy change in a process when 1 mole of that substance is dissolved in specified amount of solvent. So here NaCl solid plus aqueous gives NaCl aqueous, and enthalpy of solution is 4 kilojoule per mole. Okay, so in your practical also you have to learn about the enthalpy of solution of KNO3. Okay, so enthalpy of solution at infinite dilution means we take your solvent in large quantity, then your dilution is at infinite level. Okay, so is the enthalpy change when 1 mole of that substance is dissolved in infinite amount of solvent, that is enthalpy of infinite dilution. So if you observe ionic compound mostly soluble in water, so that ions get separated. Let us suppose your ionic compound is NaCl, so NaCl gets converted to Na plus Cl minus. Or you can take another example like KCl. KCl gives K plus Cl minus. So enthalpy change for this step is the crystal lattice enthalpy, and it is denoted by capital L, which is always positive, and the ions are hydrated with water molecules surrounding them. So all are familiar with ion dipole interaction. In that also, that ion gets surrounded by water molecule. So cation react with x mole of water. So M H2O x time, because we take x mole, and plus 1 charge is as it is because water is in neutral state. X minus react with y moles of H2O. So x is here, x should be capital. You write x should be capital. X should be capital. Okay, x should be capital X is to y minus, so you can write Na plus x mole of H2 Na H2 x plus, and Cl minus plus y H2 gives Cl H2y x minus 1 minus charge. So enthalpy change for this step is always negative, and it is called as enthalpy of hydration. Enthalpy of hydration. Now next is the enthalpy of solution is the sum of enthalpy of solution is the sum of crystal lattice enthalpy, which is related to cation, and enthalpy of hydration, which is related to anion. So for NaCl, crystal lattice enthalpy is plus 790 kilojoule per mole, and enthalpy of hydration of Cl minus is minus 786 kilojoule per mole. So what is the enthalpy of solution of NaCl? It is the sum of these two. So what we get? Plus 4 kilojoule per mole. Now, so can you answer this? So give me the answer in comment box. Okay, if you understood the previous example, you can easily understood. Okay, then thermochemistry. Next part is thermochemistry. So it is this thermochemistry deals with enthalpy change in different chemical reactions. So the R is the subscript. So let us consider the reaction A moles of A plus B moles of B gives C moles of C plus D moles of D. Remember that capital A, B, C and D are the chemicals, or they are chemical compounds, and small a, b, c and d are number of moles of that components. So let us consider A, and all are familiar with that. A and B are capital A, B are reactant, capital C and D are product. So how will you calculate the enthalpy change for any chemical reaction? Remember that if it is a chemical reaction and enthalpy of the components are given, then enthalpy of any reaction is the summation of enthalpy of product minus summation of enthalpy of reactant. Okay, multiply by their number of moles which are involved in the balanced chemical equation. So enthalpy of this reaction is equal to, these are the C and D are the product, having C and small c and D are the number of moles, and A and B are the reactants, small ab are the respective number of moles. So C into enthalpy of C plus D into enthalpy of D minus A into enthalpy of A plus B into enthalpy of B. So capital HA, HB, HC and HD are molar enthalpies of ABCD respectively. So enthalpy of reaction is summation of enthalpy of product minus summation of enthalpy of reactant. So what is the definition? It is the difference between sum of enthalpies of product and that of the reactant with each substance in definite physical state, and their amount, that means number of moles, being represented by the coefficient involved in balanced chemical equation, that is stoichiometric equation or stoichiometric coefficient. Now all are familiar with exothermic and endothermic reaction. So exothermic reaction means heat is given out, endothermic means heat is absorbed. So the enthalpy of the reaction can be positive or negative, depends on the summation of enthalpy of product and summation of enthalpy of reactant. So if your summation of enthalpy of products is greater than enthalpy of summation of enthalpy of reactant, then this subtraction is positive. And if enthalpy or heat is absorbed, then all are familiar with that, it is endothermic reaction. If summation of enthalpy of product is less than summation of enthalpy of reactant, then delta enthalpy of reaction is negative, and this indicates that reaction is exothermic because heat is given out. So some examples are given. Nitrogen plus oxygen gives nitrogen dioxide. Here it is plus sign, means reaction is endothermic. And decomposition of potassium chlorate gives 2 KCl plus 3O2 gives minus 78 kilojoule amount of heat of reaction. So it is a exothermic reaction. So from the value you can easily identify the reaction is endothermic or exothermic. So it may be asked in your question, identify whether the reaction is exothermic or endothermic. So reaction and their values of heat of reactions are given. Or in heat of reaction, enthalpy of reaction is same. Now standard enthalpy of reaction. So simple enthalpy of reaction is denoted by delta RH, and if it is standard word is mentioned, then write down 0 or degree that you know. So standard means you have to measure that enthalpy at 1 bar pressure and 298 Kelvin. 1 bar pressure, that means 1 atmospheric pressure. Okay, so thermodynamic standard state. And what is the concentration? Concentration is always refers to 1 molar concentration. Now remember that standard state of certain element and the compounds like hydrogen, then oxygen, nitrogen, they are in gaseous state. Mercury in gaseous state. Then sodium, then carbon in graphite form, which is the natural present abundant isotope. They are in solid state. Then some compounds like ethyl alcohol is in liquid state, calcium carbonate in solid state, carbon dioxide in gaseous state, then water in liquid state, calcium. So we consider this state at 1 bar pressure and 25 degrees centigrade. Now we have to consider thermochemical equations. So there are some guidelines for writing the thermochemical equation. So we follow these rules. Consider the balanced chemical equation for reactant and product. So value of this heat of reaction, it should be appropriate sign of enthalpy change is given out on right hand side of your equation, and it is denoted with delta R H00 for standard heat of reaction or enthalpy of reaction. Then we have to mention the physical state of that reactants and product. S for solid, L for liquid, G for gases. Okay, so you have to mention that in your equation. So given value of delta R H0 assumes that reactions occur in given direction, and delta R H0 for reverse reaction is equal in magnitude, but sign should be opposite to that forward reaction. And this indicates that if your forward reaction is exothermic, reverse is endothermic, and vice versa. Or you can say that if forward is endothermic, backward is exothermic. When the coefficient means that numbers used for balancing the equation, that is called as coefficient, indicating that the number of moles of all substances in thermochemical equations are multiplied or divided by certain numerical factors. So for balancing purpose, if we use some numbers which get multiplied or divided to your given equation, then the delta R in standard enthalpy of reaction also get multiplied. If we multiply the equation, multiply the value of delta R H0. If we divide the equation, then divide the value, that is and it can be multiplied or divided by same number or same factor which is used. So here one equation is given: methane CH4 plus 2O2 gives 1 mole of CO2 plus 2 times H2O liquid, and then standard enthalpy of this reaction is minus 890 kilojoule. So this indicates that when 1 mole of CH4 react with 2 moles of oxygen gives 1 mole of carbon dioxide and 2 moles of water. Now this is C2H2 means acetylene react with 5 by 2 O2 molecules to give 2 moles of CO2 plus 1 mole of water. So how much amount for standard enthalpy for this reaction is minus 1300. Now so multiply this equation by 2 and write down the reaction. So if you write the reaction, what do you write? 2C2H2 plus, now 2 into 5 by 2 means 5 O2 gives 4CO2 plus 2 H2O. Then multiply this value also by 2, so it becomes minus 2600 kilojoule. So this is the answer of first question. And equation is reverse. Then write down the reverse equation. So 2CO2 gas plus H2O liquid gives C2H2 gas plus 5 by 2 O2. Then what is the standard enthalpy of reverse reaction? Only change the sign. Here minus, write down plus. So plus 1300 kilojoule. Now next is the standard enthalpy of formation. Consider H2 gas plus 1 half O2 gas gives 1 mole of H2O liquid. So enthalpy of formation of water is minus 286 kilojoule. And this is standard enthalpy of formation of water. So what is the definition? Standard enthalpy of formation of compound is the enthalpy change that accompanying a reaction in which 1 mole of that pure compound in its standard state is formed from its constituent element in their standard state. So you can easily remember. So water is in liquid state, hydrogen and oxygen are in gas state. These are the standard states. And we have to always write this value for 1 mole of that substance. So it is the enthalpy change that accompanying a reaction in which 1 mole of that pure compound, here water, in its standard state is in liquid state is formed from its constant element, that is hydrogen and oxygen, and they are should be in their standard state. Now consider the formation of methane. So see in graphite, graphite is the stable form of carbon isotope or carbon allotrope plus 2H2 gives CH4 gas. So what is the value? Minus 74.8. This is the enthalpy of standard enthalpy of formation of methane. So we can't prepare methane like this. So it is the assumption or hypothetication. Now next is the standard enthalpy of reaction from standard enthalpy of formation. So delta R represent enthalpy of reaction and delta F means enthalpy of formation. If it is 0, standard word is the word involved in your meaning. Standard enthalpy of formation of element is always considered as 0. So element are in atomic form. H2, hydrogen is the element, chlorine is the element, carbon is the element. So enthalpy of formation is 0. Remember this. Carbon in element form, water, hydrogen and chlorine in molecular form, but they Here standard enthalpies are considered to be 0. Standard enthalpy of formation of compounds is equal to its standard enthalpy. So enthalpy of formation of compound is equal to enthalpy of that compound. So A moles of A plus B moles of B gives C moles of C plus D moles of D. Standard enthalpy of reaction is given by standard enthalpy of formation is equal to C into standard enthalpy of C plus D into standard enthalpy of D minus A into standard enthalpy of A plus B into standard enthalpy of B. Enthalpy of formation is equal to enthalpy of that compound. So it is equal to C into standard enthalpy of formation of C plus D into standard enthalpy of formation of D minus A into standard enthalpy of formation of A plus B into standard enthalpy of formation of B. That means sum of the standard enthalpy of formation of product minus sum of the standard enthalpy of formation of reactants. So remember this. Okay. So remember these formulas. So we'll solve some numerical based on this. I'll make separate video for that. Standard enthalpy of combustion C2H2 plus 5 by 2 O2 oxidation of acetylene plus 2 CO2 plus H2O liquid. So enthalpy of reaction, it is a combustion reaction, is minus 1300 kilojoule. So in this reaction standard enthalpy change of oxidation of acetylene is minus 1300 kilojoule is the standard enthalpy of combustion, because the reaction is combustion. So enthalpy of reaction is nothing but enthalpy of combustion. So how will you define the standard enthalpy of combustion? It is the enthalpy change of a substance accompanying a reaction in which 1 mole of that substance in its standard state undergo complete oxidation or is oxidized completely. So most of the words are same. We have to identify the process and write down the definition. So write thermochemical equation for complete oxidation of 1 mole of hydrogen. Standard enthalpy change of that reaction is minus 286. So what is that? H2 plus O2. 2H2 plus O2 gives 2H2O. So what is that? Standard enthalpy, it is minus 286. So it is same. Okay, we'll check minus 286 here. That equation for 2 moles, always write down reaction for 1 mole. So H2 plus 1 half O2 gives 1 mole of H2. It is minus 286. So this is the standard enthalpy of formation of water, and which is same for standard enthalpy of combustion of hydrogen. Okay. Now next is the bond enthalpy. Consider reaction H2 gas gives H2 H gas plus H gas. So it is nothing but atomization. So enthalpy of this reaction is equal to 436.4 kilojoule per mole. So H2 gas get decomposed into gaseous atom. So we break the HH bond. So it is a bond enthalpy. So enthalpy change required to break a particular covalent bond in 1 mole of gaseous molecule to produce gaseous atom or its ion. That is called as bond enthalpy. So as H2 molecule is formed due to covalent bonding, we get an atom. If we consider NaCl, we get a radical or cation and anion, positive negative radical, because they are formed due to ionic bonding. That's why these two words are mentioned. Write the equation for bond enthalpy of Cl-Cl bond in Cl2 molecule. Only the change is, instead of H2 write down Cl2, here Cl gas, and what is the bond enthalpy? It is 242.7 kilojoule per mole. So it is plus sign, means we have to supply that much amount of heat to break that bond into atom. HCl molecule dissociate. HCl, we break the H and Cl bond, so gives H gas plus Cl gas, and it is 431 kilojoule per mole. So when we have to break a particular covalent bond, we have to supply that much amount of heat. Average bond enthalpy in polyatomic molecule. So polyatomic molecule means, poly means many, atomic means the number of atoms are more. So H2O gas gives 2H plus 1O gas. So enthalpy of this reaction is 927 kilojoule per mole. So here each covalent bond in polyatomic molecule is associated with its own specific bond enthalpy. So we can write this H2O. There are two bonds. One that bonds are HO bonds. Two HO bonds are present in H2O, and they are same, but it requires different energy. So let us consider, because after breaking that bond, species are different. So H2O, first we break one HO bond, what we get? HO plus H. So bond enthalpy is 499, and if we break the OH bond, we get O gas plus H gas. So enthalpy of this reaction is 428. So in short, if we combine these two equations, H2O gas gives 2H plus 1O, and enthalpy is 927. So the total enthalpy change 927 kilojoule, not the twice as large of the OH bond. So what is the enthalpy of OH bond in water molecule? So for polyatomic molecule, the average bond enthalpy of a particular bond would be considered. So what is the average? 900, and if there are two bonds, so 927 divided by 2, that is 463.5 kilojoule per mole. So the bond enthalpy for polyatomic molecule considered as a average bond enthalpy. So if there are two bonds, divide the total bond enthalpy by 2. If there are three bonds, divide the total enthalpy by 3. So in this way you can calculate the bond enthalpy, but you have to remember that all the bonds should be identical. Now next is the reaction involving, so in case of this methane, there are 4 CH bonds. So bond enthalpy for each bond breaking, so all the bonds are CH identicals, but the species after breaking one bond, then the product will be different. CH4 gives CH3 plus H, bond enthalpy is different. CH3 gives CH2 plus H, bond enthalpy is different. CH2 gives CH plus H, bond enthalpy is different. CH gives C plus H, bond enthalpy is different. So if we add all these 4, so we get 1664. So we have to take an average. Now next one is the reaction and bond enthalpy. So all are familiar with, if we have to consider the enthalpy of, standard enthalpy of that reaction with respect to enthalpy of formation, then we write a formula. Enthalpy of that, standard enthalpy of that reaction is the summation of standard enthalpy of formation of product minus summation of standard enthalpy of formation of reactant. But when we consider that enthalpy change of that particular reaction with respect to bond enthalpy, then the formula will be different. So summation of enthalpy of bond enthalpy of that reactant minus summation of bond enthalpy of product. Okay, remember this. Okay, so here we consider the covalent bondings. Consider the reaction H2 gas plus I2 gas gives 2HI gas. So enthalpy of formation of this reaction is means formation of HI gives, so what is the reactant? H2 and I2. So here F is not the word, it is, so you have tried the which bond is present in that particular reactant. So H2 contain HH bond, I2 contain II bond, and HI contain HI bond. So bond enthalpy of hydrogen plus bond enthalpy of iodine. So these are the reactant, so their addition minus how many number of moles of HI will be produced? 2. So 2 into bond enthalpy of HI. So substitute the values and calculate the answer. Okay, in this way you can calculate the bond enthalpies. So next one is, I mentioned that law, this is law of constant heat summation. So this law states that overall the enthalpy change for a reaction is equal to the sum of the enthalpy change of individual state, or enthalpy change accompanying a chemical reaction is independent on the path followed by that system, but it depends on initial and final state. So enthalpy change for a reaction is same regardless of the path by which reaction occur. So it is a direct consequence of the fact that enthalpy is a state function. Just when we discussed the enthalpy of sublimation, at that time I mentioned this law. So let us consider the example. So 2H2 plus N2 gives N2H4 gas. So this is the first reaction, and what is the enthalpy of this reaction? Standard enthalpy is plus 95.4 kilojoule, and N2H4 gives plus H2 gives 2 times of NH3. So enthalpy of second reaction is, enthalpy of reaction 2 is equal to minus 187.6. Now what is the combined equation? Write down reactant to reactant and product to product. So 3H2, 2 plus 1, 3H2 plus N2, N2H4, N2H4 get cancelled, and product side we get 2 NH3. So what is the enthalpy of overall reaction? It is the enthalpy of reaction 1 plus enthalpy of reaction 2. So if we add these two, means to subtract 95.4 from 187.6, your answer is minus 92.2 kilojoule per mole. So sum of the enthalpy change for step 1 and 2 is equal to the enthalpy change for overall reaction. So enthalpy, so this is the formation of ammonia, and we can prepare ammonia by N2 plus 3H2 gives 2 times of NH3. So again that amount will be same. Okay, so enthalpy change accompanying a chemical reaction is not depends on the path by which reaction occur, but it depends only on initial and final state. So many times question may be asked on this topic, state and explain Hess's law. So you write the statement and write down one example. Now, what is the application? Some reaction which cannot be carried out in laboratory, or which cannot be takes place as it is directly. So if we know how to calculate the enthalpy of that reaction which cannot be carried out, so such a reaction, such a enthalpy can be calculated by using this Hess's law, by knowing the enthalpy of another reaction which can be carried out in laboratory or which can be possible experimentally. Okay, so some will solve the numerical based on all these points later on. Thank you.